Hi guys, how's it going? So, you guys have been traveling a lot, thinking a lot, publishing papers, all that jazz. What is the problem that has occupied a majority of your thoughts over the past few months?
Well,
What?
for me, at least, one big problem that I would say maybe the past few weeks, just because it's been very exciting, has been plasma cash. There's been like a whole bunch of problems with representing fungible assets in plasma cash, and thanks to a blog post that Vitalik wrote pretty recently and some other kind of research collaborations, we've kind of made some really significant progress in that area, and that has been super fun.
Yeah, and I've been helping a lot on the plasma cash side too, but aside from that, on the Ethereum core side, as I think I've said a couple of times recently, we really are at the point where all of the kind of big fundamental problems are basically solved, and it's more a whole spattering of little things about how to make it more efficient, how to Merkleize state more efficiently, how to do sparse Merkle trees more efficiently, how to do transitions between validator sets, and all sorts of kind of smaller problems like that that'll contribute to making the Casper Beacon chain spec much more efficient.
Yeah, so for me, a lot of the research that I've been focusing on is a lot related to plasma, as well as coordination mechanisms, as well as sort of inter-blockchain and interstate communication. So like, within one blockchain, if you have, global state and then localized state, that's principally the areas of my scalability research is around, and plasma is a facet of that, whereby, you don't want everybody in the world validating something because that's too expensive. So you need to necessarily split that up in terms of the validation. But then there's trade-offs in terms of, different security parameters and things like that. So a lot of research is around that stuff. And with coordination mechanisms, it's a lot of things like, faucets, airdrops, and things of that nature, whereby, a lot of those constructions may enable sort of certain kinds of social coordination that were not possible, pre-blockchain.
Hashtag handshake. Juicy question. What mechanisms are many people excited about that scares you?
And on-chain governance is kind of the obvious one, I would say. I mean, the reason why people are excited, I think, is kind of obvious, which is that a lot of people like the idea of blockchains being more kind of fully automated, being able to do upgrades without kind of complicated political processes and so forth. But at the same time, I think people seem to think about governance mechanisms with much less kind of crypto economic rigor than they used to think about consensus algorithms. Right, like in a consent, in one of these, like most of these kind of coin voting, on-chain voting, whatever mechanisms are just horribly vulnerable to collusion attacks, horribly vulnerable to bribe attacks, tends to have kind of plutocratic incentives where if you have 2% of all the money, you can vote on one slot and you can gain access to kind of higher plutocratic special interest rates. And then if you have 4%, you get double the plutocratic interest rates on double the money. And I mean, there's definitely been even high-profile cases recently of many kinds of collusion even being uncovered happening in reality. So, no, it's definitely not true that kind of large actors in the cryptocurrency space are willing to kind of pass up opportunities to earn millions of dollars just for the sake of being nice for the good of the crypto ecosystem. And I'm just, given like both the lack of kind of good, sensible mechanisms and the facts that we really want blockchains to represent the interests of users and not just the interests of kind of likely more concentrated groups like token holders and miners. I think in most cases, like the reality of what makes sense is kind of far lower than what a lot of people are kind of expecting or reaching for.
Another mildly scary thing is the free option problem with HTLCs that are like kind of long running, or actually just atomic swaps in general. So this is actually a problem that a bunch of people have been talking about, and that I've been kind of, for instance, Jane actually put up a post recently, and we've had to deal with this even in our, Plasma kind of DEX designs, where essentially, making sure that people are not able to kind of wait until the price moves to complete an order, and just kind of, and that even goes in line with like, minor front running, just like the classic issues. But that was a mind expanding one for me.
Yeah, for me, I think a lot of my concerns is around the information asymmetry in this space. Now, what I mean by that is sort of like what the sort of people working in this space and what the public perception is interacting with, is thinking is sort of the narratives going on in this space. There seems to still be a pretty big disconnect. And I think a function of that is that there's just, not enough people working in this space and doing research and sort of communicating. And as a result, you see types of dynamics where people are working on projects which seem to be very consumer-facing, and definitely, it's very important to do that kind of stuff right now, but, people don't really understand that it's very early stages. And sort of a manifestation of that is sort of the issue that I've noticed is a lot of the crypto economic mechanisms seem to really only work if there's a lot more research being done on things like peer-to-peer oracles. So, decentralized oracles is probably a huge dependency of a lot of, proposed designs and projects, which don't really there's only really one or two projects even testing it, and everyone else is just like, oh, okay, here's an empty box, let's assume that this will get made. So if you're doing, if you're maybe a college student or someone doing research in this space, or like maybe a PhD or something like that, I think definitely, definitely focus on peer-to-peer oracles if it, cuts your fancy or something, because, I think that's one of the biggest concerns that I have when it comes to technological development and the pace of technological development in this space, because you see things like, okay, scalability, privacy, things like that. There's a lot of people working on and researching, and it seems like especially a lot of the consumer level stuff probably may be dependent upon this kind of research, and I feel like it's severely under researched right now.
Yeah, so there, is a ton of research that needs to be done. And it's cool that you guys have been working with Glenn Weil, who's part of the algorithmic game theory community. And congrats, Vitalik, on the paper you just published with him. But why haven't we seen more engagement from the traditional economics or mechanism design community in crypto?
So I think actually part of it is similar to what Joseph was just talking about, where communicating the problems that we're having and kind of onboarding people into the space is really important. The critical thing is that these are design patterns for decentralization, and an outsider might see this as oh, this is a kind of weird niche use case that people are, these crazy people are working on. But really what it is these are the ways that we should be designing decentralized internet protocols moving forward. And so getting that across to people on a broader scale, I think it's a very natural thing, and we've actually been, I went with Vitalik to algorithmic game theory conference, and it was pretty amazing and eye-opening, because the stuff that they're working on is directly related to a lot of the things that we are already.
Yeah, and I'd also say that kind of from my experience historically, the kind of economics, game theory, mechanism design space doesn't, its history and kind of the things that it focuses on have not been this as close to kind of direct tinkering and engagement as, for example, the cryptography and distributed systems community, which actually did jump on the crypto bandwagon very quickly. there is the idea that economic mechanisms just are something that you can tinker with and just deploy to a wide variety of contexts as something that is maybe and definitely starting to appear through kind of centralized Web 2.0 ride sharing like, and similar kinds of platforms, but otherwise, like it's large portions of the space are still either doing kind of highly theoretical mathematics that's pretty far from actual application, or arguing whether tax rates should be 39.6% or 37.8%, or kind of other things that are like not directly conducive to kind of just pivoting over and starting to think about like optimizing proof of stake algorithms. But that's definitely not true of the entire community, and I think we have been kind of good at increasingly starting to get better at finding the kinds of people that are like more interested in like, both the kinds of problems that they can help solve for the blockchain community, but and also the areas where blockchains might be useful in solving their problems. So, and some of the kind of economists at George Mason have been kind of quite friendly recently, and a lot of Glenn Weil's work has been kind of more and more tied in with blockchain stuff. So, and it's happening later than crypto and distributed systems people, but I'm optimistic.
Yeah, I've noticed that a lot of it could also be that we're not at a stage where, a lot of traditional economists where research is relevant because like, traditionally economics has been separated into macroeconomics and microeconomics, but it's most relevant to, as discussed, the smaller subdiscipline of, mechanism design and mechanisms within the field of economics, which is even more specific than microeconomics. So it's sort of like macro, micro, and then like mechanism is sort of like even more fine-grained and detailed. But traditionally mechanism design has always been focused on auction mechanisms. You look at the papers in the space and it's like probably like north of 50% or even higher being related to auction mechanisms. So it's sort of like new possibilities, and really that discipline looks most applicable because like it's sort of if you apply like a macroeconomist to view under the lens of blockchain, they're probably not going to really understand it that well easily because like they're coming at it from a position very similar to everyone else. It's sort of like how in the fields of engineering, distributed systems people pick up this stuff a lot faster than people working on databases, for example. People working on databases tend to be probably the last to really understand this stuff. And distributed systems people, especially in the subdisciplines such as working on things like BitTorrent, where you're basically dealing with the same problems that we deal with, right? When it comes to traffic accounting and things like that, where someone's trying to be leeching too much, and then you kind of want to create this accounting system. Which sort of measures and creates, equitable, uploads and downloads, and that starts looking a lot like the mechanisms that sort of we're dealing with.
All right, is it that database people don't understand it, or they don't want to understand it?
No, it's not like that. I think it's just sort of in every field, there's sort of a learning curve, and that's why I've said like the fastest way to what I've seen is the people that pick up the stuff the fastest tend to play, have a history in video games, or at least games in particular, whether it be, MMORPGs, Magic Gathering, poker, things like that, simply because you sort of have that mindset already and you sort of understand these constructions. People that have, made video games or dealt with, multiplayer economies, especially, MMORPGs, tend to be the fastest.
Yeah, that's interesting. I'm helping some people hire mechanism designers right now, and I'm looking for people who play a lot of video games, per your suggestion. Okay, I have a round of challenge questions for everyone. Joseph, in what applications do you think channels make more sense than Plasma?
Anything where speed is required, and it's not a one or the other. You can run channels on top of Plasma, and that could be the construction that plays out for what a lot of people interact with. So Plasma, you're dealing with something that is going to take longer than maybe like 5 seconds probably in terms of worst case, right? And maybe as long as in extreme circumstances, maybe even an hour, who knows, right? Depending on what you're doing. So channels give you the speed, Palace gives you the transaction layer scalability as well as contracting scalability under certain contexts.
Okay, Vitalik, you have been hating and an outspoken critic of on-chain governance. So why does Ethereum have on-chain governance in the form of miner voting that determines gas limit?
Ooh, fun question. So I think the way that I would answer that is that, I mean, first of all, there have been cases where the fact that in Ethereum the gas limit is a setting that just can be adjusted up and down by miners has arguably kind of saved us in multiple ways, right? So for example, during the denial of service attacks in 2016, the miners managed to vote the gas limit down to like 1 million, and that actually made the blockchain work safely during that period instead of being kind of completely collapsing the DOS attacks as it would had the limit stayed at 4.7 million. It allowed us to have kind of multiple rounds of capacity increase without having to go through the fairly complex processes involved in a hard fork. So I think the reason why we did that is actually it was a suggestion by Andrew Miller about even before Ethereum started, which is basically that at the time we were trying to think about algorithms that could somehow dynamically adjust the gas limit in response to kind of actual levels of activity and trying to like basically elicit information from miners' willingness to create blocks of different sizes and try to use that to figure out what gas limits make sense. But then we discovered that like basically all of these algorithms that we could think about were potentially attackable. And his suggestion is, well, let's just have miners vote on it, and the default strategy will be using one of these algorithms, but if needed, it can be kind of changed over time. And the reason why those kinds of paths made sense is because, like, first of all, the gas limit is just totally not a fundamental part of the Ethereum social contract, and I don't think many people kind of perceived it as being. And second, we just had no idea at the beginning what gas limit is optimal. Had we set a fixed number, it would have been set to 3141592, and now transaction fees would have been like potentially 5 to 10 times higher than they are right now, right? So situations where it's kind of one single number and it's really not that bad if it goes up a bit or it goes down a bit, and where you can kind of benefit from responsiveness, those are more the kinds of environment, and also particularly where there aren't kind of too large incentives in trying to kind of shift it in the wrong direction, are areas where on-chain governance can actually make more sense because it is this kind of very limited form. But then applying kind of miner voting to something like should we try to rescue this wallet where a bunch of ether got stuck is something that would be kind of much more contentious, and where realistically users want much more stronger kind of guarantees and much more of a say, so it would make much less sense.
Okay, he was ready for that one. Karl, Plasma XT, Plasma MVP, Plasma Unlimited, Plasma Cash, Plasma Debit, Plasma Cash Flow. What is going on?
Fun with names, to be honest with you.
What about Plasma Classic? Where's that?
I mean, it's on its way. We'll see. Just come up with a good idea and put a Plasma Classic on it. I mean, so the kind of history of Plasma is somewhat interesting. With it's starting out with Joseph and Vitalik putting out this white paper, basically, outlining Plasma at a high level, and then iteration after iteration, first Plasma MVP came out, but we realized that there were mass exit vulnerabilities, and then Plasma Cash kind of addresses this, but it has its own weakness with fungible assets and transaction history growth, and then Plasma XT trying to address transaction history growth, and then Plasma Debit trying to address the fungibility problem, and then finally Plasma Cash Flow and Plasma Unlimited. These are the kind of the frontier, which you'll hear about soon, which addresses these in a kind of different way, both the fungibility and the transaction history. So it's basically been this like wild ride of a whole bunch of Plasma researchers all over the world. We communicate on this Plasma implementers call, a lot of us, but in fact there's a huge number of people who are implementing Plasma by themselves and just posting on ETH Research and doing a whole lot of stuff. So it's been this, of course we've got a bunch of silly names, but really what that is just a bunch of research that has been done to make this thing a full, complete vision. And I'm very excited for the next two ones.
One thing we've realized is a lot of constructions and mechanisms, you need a shorthand name for them. So we just decided to make some ha-has, and make some jokes around it. But, it's really important because otherwise the names start getting really, really long in terms of what we're communicating. So, developing shorthand names for things is necessary. A lot of the research in Plasma, a lot of it is a lot of really, really awesome designers and engineers working together, and a lot of different implementations working together, and that's what a lot of the promise lies, is in terms of the opportunity to really do fundamental research in this space and explore the sort of constructions which allow for the ends of secure scalability when it comes to developing it on the layer 2. And we all want to increase layer 1 scalability as much as possible. There's a lot of fundamental research happening in the Ethereum space with that as well. But on the layer 2, security is of a pretty paramount concern. And the original Plasma design, there's a fundamental issue when it comes to block availability. When blocks get too full or too large, essentially you're putting more of the security constraints onto layer 1, and oftentimes the interaction between the layers is the most important. And one observation is that you have to be very careful around dependence upon time on layer 2 is what we're seeing in terms of many areas of research in this space. Time is really interesting, right? The blockchain is, the notion of blocks is essentially a proxy for, the elapse of time. And at its core, you can sort of see, the root blockchain as sort of, timekeeping mechanism, right? And when you have interactions of different state, which require things to happen before a certain amount of time, then you start to ask yourself, okay, can you get that stuff in that amount of time? And you see this in society today, right? Courts sometimes get backlogged. India is an example where it's like you see very extremes of that, and it causes actual issues when it comes to judicial education. So that's a lot of the constraints that we were seeing with a lot of the original Plasma design, which is where Plasma Cash comes in and resolves a significant amount of that, but brings about other design constraints. But those design constraints can be worked around, whereas fundamentally, when you're dealing with time, that's a lot harder to work around.
Yeah, and the keeping of time is a core issue with HTLCs too, like for cross-currency swaps. Anyways, everyone, what is a topic in crypto economics that you've changed your mind on in the past 12 months? And bonus mode, what have you changed your mind on twice?
So one thing that I've kind of changed, it's a mild change. It's not a 180 degrees, all right? But at first, I was incredibly bullish on the idea that a central operator in Plasma would put down a large deposit and then all transactions going through that operator, they can receive these signed signatures saying, I promise that your transaction will be included in this order, that it will be valid and in the plasma chain. And if I lie to you with this signed transaction, you can burn my money. You can slash my bond. So I was very excited by this idea. This was one of my favorite things I would tell everyone, because I'm so excited for the day when our blockchains can update the UIs immediately. You send a transaction and you just get a check mark. That is like something I've been waiting for way too long, just like my transactions. And so this idea, I was like, great. But then I realized, like, when these systems scale up, we really do have to do a lot more analysis on what are the actual numbers of in-flight transactions at one particular time. What do we expect? Like, how can these systems, when they get really big, how big do those bonds have to be? And how much do users trust them? So, like, I didn't maybe kind of fully appreciate the complexity of, okay, now let's think about capital lockup costs. Let's think about how many in-flight transactions, because if your number of in-flight transactions greatly exceed the bond that the operator would lose, they have an opportunity to really do something wrong. So I'm kind of more skeptical, but I feel a little bit more educated.
I've definitely been slowly kind of getting somewhat more pessimistic about the original vision of DAOs over time. And I think one of the main kind of arguments about that is basically just the same points I made about mechanism design, that actually coming up with governance mechanisms that are not just horribly vulnerable to different forms of bribery and collusion, and that are also that also do something non-trivial in terms of improving beyond the basic mechanism of people having money and people donating money to who they want to, is actually kind of surprisingly difficult. And the thing that I'm more in favor of now is more kind of special purpose, kind of either partially DAO-like mechanisms. So one example of this was the idea of DAICOs that I came up with, I think it was at the start of this year, where basically you kind of have an ICO where instead of the ICO money going into directly to the developers, the ICO money goes to a smart contract, and then people have the ability to vote on how much money goes to the developer, or they can vote to shut the whole thing down. And one of the reasons why I think that model is interesting is that, first of all, it's not general purpose, it's special purpose to whatever particular ICO does a DAICO at that particular time. But also, the way that it kind of combines together the trust models basically means that in order for the trust model to fail, you basically need both the developer and the majority of the voters to be dishonest in some way. So you actually are kind of combining together security models in a nice way that has a fail-safe. As far as changing my mind twice goes, I am no longer in favor of 100% proof of stake, 0% proof of work. I'm in favor of 99% proof of stake, 1% proof of work, where the 1% is basically that I think we should have bounties to in a protocol to pay people to make heavy-duty zero-knowledge proofs like snarks and starks about various features of protocol state. And I think that's a public good that should be legitimately kind of subsidized by the protocol. And generating these proofs is complex enough that it seems like it requires some kind of reward. And it does seem like something that's very valuable for kind of light clients of all kinds. So I think coming up with those kinds of gadgets is something that we'll probably start seeing more, especially kind of in the longer term, maybe 3 to 5 years, once general purpose zero-knowledge proof technology is more mature.
I don't know if I've changed my mind twice on things, but I probably have. Yeah, more than likely, I think everyone does. The main thing, I mean, I alluded to this earlier, but I thought peer-to-peer oracles was not that hard of a problem if you looked into it enough. I think it probably does require a lot of research from a good amount of people. Originally, I was thinking like, oh, well, maybe you just have, someone propose things, and then you have like, a set of validators basically saying, okay, is this true or not? But then you really run down it, you're probably going to need a lot of layers of adjudication, would be my guess. For those in the crowd not familiar with this problem, it's just basically how do you have blockchain sort of measure things in the real world? The idea is once you have some kind of black box that does that, ideally it's like a simple mechanism that is replicable or tunable to whatever it is you're trying to do. Then at that point you can sort of do basically anything when it comes to group computation. The idea is that it would probably be, people or user agents or whatever it may be, people or proxies for people basically evaluating whether something happened or not. An example of that would be, let's say you wanted to use handshake-like mechanisms that incentivized people to put up Wi-Fi access points, right? A lot of the existing sort of mesh networking projects don't really make sense because you're like, well, how are you going to bootstrap, right? Well, if you could construct it so that the blockchain itself distributes out coins for let's say putting up Wi-Fi access points. Let's say you get like $100 worth of coins for putting something up. Well, then that works. But the problem is then you're dealing with Sybil attacks, and then at that point you need to measure whether someone's available, and that's going to require user basically some type of peer-to-peer validation. That's going to need people to ensure that it actually happened or some type of action occurred. And once you attach, validation of action with, economic incentives directly with the chain itself giving you those economic incentives, then you have this combination that could be pretty useful, especially on the consumer side. My original kind of thinking was, okay, maybe not that many people working on it because it's sort of like, it could be solvable for whatever use case, but I think it's because it probably requires a good amount of research.
Do you think that there'll be like a general purpose peer-to-peer Oracle thing that we can kind of come up with, or is it like use case specific?
I think maybe like the base algorithm could be like,
okay, cool.
Maybe, I don't know, right? Because I don't know what one looks like. Yeah. But probably get one that works and then see what the commonalities are. I assume there's a lot of commonalities, right? It probably involves something like, maybe you have 10 people validate or one person validate, and maybe like anyone can dispute, and then it goes to like, like maybe 10 people, and after that they have to pay some cost, and then they bond it, and maybe it doubles again or 10 times again, and then you sort of like have the social cost paid for by the disputes. So it's sort of like the like civil court cases where in jurisdictions where the person suing bonds for the cost of the court case or something like that. I don't know. I don't know what it looks like, right? But I think a lot of good research that needs to happen.
Yeah, I always like hand waved and said, oh, people will come up with their use case. But yeah, you're right. We need some research on this. This is cool.
Yeah, but the notion of like having that bonded up, having people validate that. I don't know. That's one of those things where I feel like a good third, maybe over half, who knows, however many of these projects out there probably need this.
Yes.
Okay, incentives are based on humans, and humans change over time. Is game theory useful for humans, considering that they're so hard to model? How do you, compensate for the small game fallacy in your process, in your work?
This is one of my favorite questions. So I think of like creating these crypto-economic mechanisms a lot of the times as kind of creating single points of failure, isolating those single points of failure, and then defending them as much as possible. So kind of like, Sparta with the kind of the cliff, and you're like 300, defending off the Persian army. We have no idea how big the Persian army is going to be, as in we don't know how big the incentives are to kind of mess up your system are going to be, but we can defend that one choke point as well as possible. And so, like, for instance, a choke point for Casper, right, is, finalizing two conflicting histories, right? That is a choke point. That is a fundamental problem with this space. And so we can analyze the incentives to some extent. We can say, okay, we don't know how much of an incentive someone might have to fork the network, but we do know that we can impose the maximal cost on them for doing this. And I think, that's kind of the best we can do, short of simulating the universe. But we can't, that is actually very useful, right? Just the knowledge that if something goes wrong, there will be some kind of, there's a plan B or there's some defense against it, I think is really, really critical for us trusting our internet infrastructure.
I would say, I mean, first of all, the game theoretic incentive models are not the only models under which we're analyzing these protocols. So, like, for example, I mean, Casper is secure under a certain set of economic models, but it's also secure under the very traditional kind of two-thirds honest majority BFT assumption. So it's, like, I think our goal should be to have protocols that are secure under as large an array of kind of realistic sets of assumptions as possible. And I mean, I definitely agree that kind of human motivation is complex. Sometimes there's irrationality, sometimes there's more coordination and collusion than you were anticipating, which is, I think, a huge flaw of a lot of the kind of traditional academic mechanism design space. There's also just people that have incentives that you weren't even thinking about. But the reason why mechanism design analysis is useful is because like economic incentives are this one component of what drives human behavior that is kind of constant across a very large array of circumstances, right? Like it's like people like having more money than less money, regardless of whether they're in the U.S. or China or North Korea or some ancient tribe that hasn't been contacted. Although in their case, it wouldn't be money; it would be some other kind of resource. If they're corporations, autonomous agents in the future. And so, if we want to design systems that are socially scalable and that work kind of across the entire world, and that will work across different periods of time without having to kind of have a big constitutional convention and redesign the rules every 5 years forever, then relying on like mechanism design and incentives as a kind of primary bulwark of security, I think, is still a kind of very smart choice, as long as you're not creating a fragile system that breaks as soon as even one of your assumptions is broken.
Yeah, the goal is, you know, you make things resilient against assholes, right? You can't trust people to be nice, right? And that's all it is, right? I mean, like, it's the Hobbesian dilemma. It's you know, the Leviathan, right? Well, it's like, well, you gotta have someone, you gotta have something running it in order for this thing to work. Society, right? What do? Well, you know, traditionally you just pick someone to do it, and that person turns out to be a jerk. Now what, right? And it's like, well, that person's a jerk because, like, you know, everyone wants to be that guy. Well, now what, right? You know, now the only people that want to do it have to, like, you know, have to defend against other jerks. Now it's like, oh, great, you know, that's the problem with society, and that's why we're all doing this, right? So that, you know, we can do good work and not defend against jerks all the time, because it's just this box that's defending it, right? Like the blockchain is meant to be resilient against those kinds of attacks, and you have to do it with the presumption that, you know, self-interest is at play, and you know, it has to be reasonably decentralized, or else, you know, everyone's going to vie to play that role. And the game is set up, you know, so if we're talking about game theories today, right, the game is set up so that only assholes will want to do it, because it's not a fun job to defend against other assholes. It's only fun for assholes, right? So that's sort of the game theoretic result that we have. When it comes to the economic mechanisms in this space, you know, you have to be fairly resilient from the eye of decentralization. So a lot of the existing, you know, mechanisms tend to assume, you know, in cryptography speak, you know, it's sort of like, you know, trusted dealers and things like that, and that sort of, you know, defeats the whole purpose of, you know, all these mechanisms.
I think that's the first time I've ever heard assholes and game theoretic result in the same sentence.
Well, you know, you have that imperative for positive ends rather than negative, right?
Got it. So I know in past panels, you guys have been on a lot of panels together. Joseph has in the past asked a really great question, which is, you know, what experiences outside of crypto in your life generally have influenced your lens on mechanism design. But what I want to ask is, how have you guys influenced each other through the process of working each other in how you approach these? Oh, Carl's got this one.
I'm sorry, I reacted. I didn't realize that means I had to be first. Well, my goodness, I don't know. Okay, I can say that the amount of mathematical rigor that I now kind of feel is necessary and kind of work through has dramatically increased ever since spending a lot of time with Vitalik. Vitalik is incredibly rigorous and very, 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 into specifying all of the kind of details and figuring out, okay, how, let's calculate how many bytes this is, are going over the network, and like, let's do this as soon as possible so we can, either realize that our protocol is fundamentally broken or that it works and it's efficient. And so like really, really thinking these things through and kind of like, instead of going from the cloudy haze that is, my brain unrestrained, and kind of putting it into a, clear form. This has been very, very, very valuable to me, so thank you.
I think one of the kind of interesting aspects of Ethereum culture that we've kind of stumbled into, and sometimes people criticize it for being unproductive, but I more and more realize that it's like awesome for productivity as well, is how we're kind of always traveling everywhere and have this mix of kind of having time to work by ourselves and also coming together every couple of months at places like conferences. And the reason why I think it's interesting is because it allows us to kind of have our own strands of thought and our own strands of research. I mean, including myself and Karl's work on Plasma, Joseph's work on Plasma, Vlad's kind of completely independent work on Velasper and Vlarding and whatever somewhere out there in the abyss. And like we're both kind of independent enough that we like have all of the, kind of separate strands, and we don't sort of confirmation bias each other into being closed-minded to the point of oblivion. But also, we have the opportunity to think separately, read separate things, interact with other kind of intellectuals inside and outside the space, and then every couple of months we come together, and when we come together, each of us has like 3 or 4 new interesting ideas to share to each other. And it's, and I think that combination of kind of different people attacking problems from different styles and different sets of assumptions, but still at the same time being kind of close to each other and friendly to each other, that you benefit from the diversity rather than it turning into some kind of tribe war, has been hugely beneficial for Plasma, hugely beneficial for Casper, where even Casper FFG has absorbed a huge number of ideas from Casper CBC. And in general, it's contributed significantly to our research.
Yeah, I think a lot, I would echo those points. I think a lot of it is related to the fact that a lot of the mechanisms, the crypto economic mechanisms in particular, I'm separating this out from the engineering side, but the mechanisms in particular feel like a reflection of your personal tendencies and who you are as a person and what your values are. And I don't mean like political values necessarily. I mean like, what you think is the most important for you, And as a result, interactions with other people in this space is not only helpful for yourself, but also helpful for, it's sort of like the information sharing is absolutely critical in this space, simply because you don't want to be too myopic with your own tendencies, right? Ideally, the development of a group of people is sort of the way you sort of, check that. And that's a big benefit for interacting with, not only, the people on the stage, but also, everybody in particular. And I think that's why, the crypto economic community is very nascent, but we do need to talk to each other. We do need to interact with each other because, oftentimes the mechanisms that we're researching, is going to be a reflection of our own tendencies.
I think one thing I've noticed from spending time with all of you is that you guys are all very creative. And I think from Karl, I've learned compassion. From Vitalik, precision, most definitely. And I think I've learned a lot about integrity from Joseph. That's all the time we have. Thank you guys for joining us today.